Hello students, welcome back. Now the third type we will be discussing is the radical type. It's actually called radical type because square roots are involved in this type. Okay, now equation will be written in the form under root ax plus b. This can be plus or it can be minus under root cx plus d equals to under root ex plus f. Now in this types of equation, if you wanted to solve it for variable x, what we need to do first, we need to remove these radical signs. As soon as we remove the radical sign, what will happen, that the variables will be free and then we can easily find out the value for x. Now let's see how this these types of equations are solved. Alright, for example, now this is the equation under root y plus 21 plus under root y plus 5 equals to under root 6y plus 40. Now as I told you that to solve these type of equations, what we are going to do is we're going to remove this root sign. Alright, now we know that how we can remove under root sign, and that is by squaring both the sides. Alright, now if I just square both the side, now first of all I cannot square it individually, like I can square y plus 21 individually, y plus 5 individually, and then 6y plus 40 individually. I can do it on this part but not on this. This can be wholly squared. Why? Because of this plus sign. It's written in an equation form, and we cannot just square it and consider it as a single term and then square it. Alright, so we need to consider it as one term, and if I just said that I need to square both the sides, this is how we are going to square it. Okay, so I've squared both the sides. Now this side can easily be solved, and this side, for this particular side, we know the formula for a plus b whole square. Alright, okay, now we will be using squaring formula to expand equation A. Now how this thing is done? Okay, we know a plus b whole square is equals to a square plus 2ab plus b square. Alright, here in equation A, let a equals to under root y plus 21 and let b equals to under root y plus 5. Okay, now if I just, it was written in this form that a plus b form equation A. If one side of the equation was written in this form, now I can expand it in this form. Alright, so how this is done? It's a square under root y plus 21 square plus 2 formula to a under root y plus 21, b under root y plus 5 plus b square, that is under root y plus 5 whole square, and the 6 under root 6 y plus 40 whole square written as it is. Okay, and I've squared both the sides. Now this is what the result is. These squared value, just radical sign is now removed from this part and from this part and from this part. Okay, so the values will be y plus 21, y plus 5 plus 2 under root y plus 21 and y plus 5 equals to 6y plus 40. Alright, now what I have done out here is that I have added that is, I have just removed the bracket sign. Now as you can see, the equation is now written as y plus 21, y plus 5 plus 2 under root y plus 21 under root y plus 5 equals to 6y plus 40. Okay, the next step that I'm going to do out here is, okay, if I add y plus y, that will give me 2y, and I add 21 and 5, this will give me 26. Alright, after that what I'm going to do is that I'm going to shift all these terms, these two terms, on the other side of the equation, because I really need to solve this radical sign, because as we said that in order to solve such equations you need to remove the radical sign, and as you can see out here there are still radical sign remaining. So what I'm now going to do, that I have written it here, okay, on one side, and I will be moving these two terms on the other side. As you can see, it earlier it was 6y plus 40, now 6y plus 40, this was plus 2y, now it is y minus 2y, it is plus 26, now it is minus 26. Okay, Okay, now we will be solving it. That is 6y minus 2y, that is 4y, and 40 minus 26 is 14. All right. Okay, and as far as these two terms are considered, they can be written as 2 under root y plus 21 and y plus 5, and this is done by using logarithm rule. When bases are different and power are same, you can write it, you can write them in this like this. Okay. Okay, now what happened is that, as you can see, this 2 was remaining. Okay, so I know 4y plus 14 are also multiple of 2, are all are divisible by 2. I'm sorry. Okay, now this 2 is remaining, so what we are going to do is that I'm going to shift this 2 from this side to the other side of the equation. Out here it is multiplying. When it will go to the other side of the equation, this 2 will be divided by, will divide both the terms. Okay, so after doing that, this is what my result is. If I just divide this equation by 2, I will get 2y plus 7, and radical sign, as you can see, it is now as it is written, okay, on one side, and the remaining terms on the other side of the equation. All right, now I will be squaring the above equation again in order to remove this radical sign. Okay, when I do that, this is what the equation will look like. If I just square these two sides, you see this is this basically is an equation written, so it will be squared like 2y plus 7 whole square, and this part, if squared, will remove the radical sign. Now first thing is achieved out here, that we have removed the radical sign. Now what is left, we can easily solve by using multiplication, or and by expanding the other part of the equation, that is this part, by using squaring formula. Okay, what I have done here, if I just go back, I have I will now be multiplying these two brackets, and I will expand this this term by using squaring formula, and this is how it is done. Y square plus 26y plus 105 equals to 4y square plus 28y plus 49. All right, now what we can do is, then we're gonna simplify it a little. Okay, and after simplifying it, this is what my last final quadratic equation will look like, or you can say the equation is now converted into second order equation into quadratic form. And now we can easily solve this equation by using perfect square. You can use factorization if applicable, or you can use quadratic formula. Okay, now after solving it, these are my results. Okay, 3y plus 14 and y minus 4 equals to 0, and I got my values, that is y equals to minus 14 upon 3 or y equals to 4. Now I have written or. Okay, or now these types of equations, especially when radical equations are there, you need to verify your solution. Not both of the solutions are correct. Sometimes it happens, while sometimes it doesn't. Okay, so you need to verify this answer. Now how will you verify it? You just substitute these values into your question which is given to you. If right hand side and left hand sides are equal, then we can say that the solution, that the value satisfies the equation. And if it doesn't, that means that that particular solution is not the part of my equation. It is not the solution of my equation. That value of y is not required. It is not the solution of my equation. Now I have done verification, and I have said that verification shows that y equals to this minus 14 upon 3 does not satisfy the equation, and hence it is an extraneous solution and cannot be included in the solution set. That means that the solution set only consists of this is the only solution, possible solution, not this, because this value is not satisfying my equation. Sometimes what happen is that whatever the answer we get after solving a final quadratic equation, both the solution satisfies the equation, and sometimes there are cases when it doesn't. So we need to check that which solution verifies and which doesn't, and only after that we will put it in solution set form. Okay, if we just go back and just have a quick revision of what we have to do in radical equation, then it will be, this is basically the radical equation. What we need to do in this type of equations, that we are going to remove this radical sign, and as soon as we remove this radical sign, we'll see that the equation will move towards turning into a quadratic equation. So out here we don't need to suppose anything. Like in the earlier equations, what we were doing is that, or earlier types, we were supposing another variable in order to convert that particular type into quadratic form. In radical form, in this radical form, what we have done is we have just removed the radical sign, and after removing the radical sign, what we saw is that the equation after simplification has turned into a quadratic form. Okay, and after solving that quadratic form, we got a desired roots. Now those roots needs to satisfy the equation. That is a mandatory condition in these type of equations. Okay, you need to satisfy the roots out here. If the question or the equation satisfies, that means that your roots are correct, and you can write it down as your final answer. And if it doesn't, you only have to give the answer that satisfies the equation. Okay.